Assalamualaikum and good evening. This is our subject DJJ6182, which is engineering plan. The title for our case study is Impulse and Reaction Steam Turbine. We are from Group 5 and this is our part 2. Our lecturer name is Kiruzam bin Marhe and our group member is Muhammad Adam bin Rosli. The metric number is F2013. And the second one, Muhammad Loman Hakim bin Muhammad Siranto Ashrafil Khairul. The metric number is F2014. And the last one, me, Nur Fadira binti Muhammad Tamizi, and my metric number is F2016. Hello, my name is Nur Fadira binti Muhammad Tamizi and my metric number is 01DKM18 F2016. I will explain you about question 1 and question 2. Question 1. A standard diesel cycle is an idealized cycle for diesel engines. Sketch a PV and TS diagram and clarify 4 different processes for the ideal diesel cycle. The image shows a PV diagram and TS diagram for the ideal diesel cycle, where P is pressure and V the volume or V the specific volume, if the process is placed on a unit mass basis. The idealized diesel cycle assumes an ideal gas and inert combustion chemistry is housed and recharge procedure and simply follow for the same process. Clarify 4 different processes for the ideal diesel cycle. Process 1-2. Isentropic compression. In this process, the piston moves from BDC to DC, and compression of air takes place isentropically. It means that during compression, the entropy remains constant and there is no flow of heat out of the cylinder walls. Not conductor happen. Here, the air is compressed to the pressure increase from P1 to P2. Volume decrease from V1 to V2, temperature increase from T1 to T2, and entropy remain constant. Process 2-3. Constant volume heat addition. In this process, the hot body is kept in contact with the cylinder and heat addition to the air takes place at constant pressure. During the process, the piston rests for a moment at TDC. The pressure remains constant. Volume increase from V2 to V3. Temperature increase from T2 to T3. Entropy increase from S2 to S3. Process 3-4. Isentropic expansion. In this process, after heat addition, the expansion of air takes place isentropically and work is obtained from the system. The piston moves downward during this process and reaches to BDC. The pressure falls from P3 to P4. Volume increases from V3 to V4. The temperature falls from T3 to T4 and entropy remains constant. Process 4-1. Constant volume heat rejection. In this process, the piston rests at BDC for a moment and the cold body is brought in contact with the cylinder and the heat rejection takes place at constant volume. The pressure decreases from P4 to P1. Temperature decreases from T4 to T1. Entropy decreases from S4 to S1 and volume remains constant. That's all for different processes. This is question 2. The question is, assemble with contrast a block diagram that shows how the diesel engine starting system works in diesel power plant. So, this is schematic diagram of diesel power plant. In the figure show the diesel power plant. The diesel engine is one of the main components present in the diesel power plant. Mainly, the engines are classified into 2 types. They are 2-stroke engine and 4-stroke engine. In the diesel engine, the engine is straight away joined to the generator to develop power. In the engine, the air entered in the cylinder must be compressed. Fuel must be injected by the end of the compression stroke. After the burning of the fuel, the burnt gas expands and applies pressure on the piston. To the generator, the shaft of the engine is straight attached to the engine. After the completion of the combustion, the burnt gas are ejected in the atmosphere. Air filters are used to remove the dust particles present in the air during the entry into the engine. Air filters are a dry air filter type which consists of wool, felt, or cloth. In case of the old bath type filter, the air is pressured over a bath of oil, so the dust must be eliminated that get caught. The injector fuel gets ignited and combustion takes place. This liberates the huge amount of energy which is utilized to run the generator to produce the electric power. The cooling water is continuously supplied to cool the engine, and lubrication oil is supplied to lubricate the engine parts. The air intake supplies the air to the engine for subsequent operations. Fuel oil from the tank is passed through the filter where the oil gets filtered and the clean oil is injected into the diesel engine through the fuel pump and fuel injector. The mixture of the compressed air and spray of the fuel oil are ignited in the engine and the combustion takes place. The released heat energy is utilized for driving the generator, which produces power. I will pass to Muhammad Lokman to proceed the next question.
Hello, my name is Muhammad Ukman Chamber Muhammad Suranto alias Khairul. My matching number is 01 PKM 18F 2014. Question 3. Sketch the layout of basic compressed air plant. Okay, the basic compressed air plant have number 1 compressed air supply, after cooler, ASME code, compressed air tank, particulate heater, air dryer, inline ambient air dryer, and the last part is abrasive flash cabinet. Question 4. A positive displacement pump can be classified according to rotary and reciprocating type. What is the category of loop pump? Sketch a loop pump by showing the liquid flow direction in suction, discharge, and bleed. A loop pump or rotary loop pump is a type of positive displacement pump. It is similar to a gear pump, except the loops are designed to almost meet, rather than touch and turn each other. How do rotary loop pumps work? Rotary loop pumps, which are self-priming positive displacement pumps, are not sensitive to dry running. The synchronous rotation of the rotor pair and the increasing suction chamber create a vacuum on the priming side of the pump. This vacuum draws the liquid into the pump chamber, and the pump medium is conveyed past the pump wall into the pressure area by the rotor. The synchronous rotation of the rotor pair and the decreasing pressure chamber create an overpressure on the discharge side of the pump. The flow direction can easily be reversed by changing the direction of rotation. Thank you.
Hello, my name is Muhammad Adam bin Muhammad Rosli. My metric number is 01 DKM 18F 2013. So my question is, vane pump is rotary type. Illustrate a vane pump by showing the liquid flow direction in inlet and outlet, rotor and vane. First, a slotted rotor is eccentrically supported inside siloidal cam. The rotor is located close to the wall of the cam, so a crescent-shaped cavity is formed. The rotor is sealed into the cam by two side plates. Vane or blade fit within the slot of the impeller. As the rotor rotates and fluid enters the pump, figure force hydraulic pressure push the vane to the wall of the housing. The tight seal among the vane, rotor cam and side plate is the key to the good suction characteristic common to the vane pumping principle. Second, the housing of cam fluid into the pumping chamber through hole in the cam. Fluid enter the pocket created by the vane, rotor, cam and side plate. And the last, as the rotor continue around, the vane sweep the fluid to the opposite side of the crescent, where is quiescent through discharge hole of the cam as the vane approach the point of the crescent. Fluid then exits the discharge port. Thank you.